hope all of you are doing fine. So today we will discuss LeetCode problem number 48, which is rotation of an image. So in this problem, so first we will go through the problem statement, then look at these examples, and then write our algorithm, and at the last implement the solution. Okay. So the problem statement says we are provided by n into n square matrix. Okay. So our task is to rotate the 2D matrix, and so it says we don't need to take one more 2D array. So it's like it should be in place, and we can't use an extra array. Okay. So how it should be look like. So let's say for example 1, so one after rotation of 90 degree clockwise, so 1 will go to this position, 3 will go to this position, 9 go to 7 position, 7 go to 1 position. Similarly it will look like 7 1 3 9. Similarly for 2 go to this position, which is here, 6 go to 8 position, which is here, 8 go to 4 position, which is here, and 4 go to 2 position, which is here. So that will be the expected output after for example 1. Similarly for example 2, 5 will go to this location, yep, 11 go to 16 position, yes, 16 goes to 15 position, yes, and 15 goes to 5 position, and similarly for other nodes also. So yeah, so let's start. So this is a square matrix of 5 by 5. So this is how our algorithm says. So first goes to this position, second last goes to this position, this node goes to this position, and this node goes to this position. This is for the first node. For the second node goes to this position, this node goes to this position, this node goes to this position, and similarly this node goes to this position. Similarly third node, and so okay. So let's consider the direction as well. So this direction will consider as J, and we will consider I as this direction, and we are assuming this is an array of A of ij of length n into n. Okay. So in this one, so the one thing to note is we start with this node for the outer loop, and we will end up here and not at the last node. The reason is for the first node we start with first node and manipulate the last node, and if we end up at the last node and consider the last node, in this case suppose this value is 1, so we move to 1 to here, and if we consider the last node as 1, so we move this to there. So similarly two rotation will take place for the first node, so that's why we will consider for last to previous node. Okay. So we will split our matrix in a way ki first create some subsquares. Yep. So in first loop we will consider the outer square, then the second, then the third, and similarly. Okay, cool. So let's see how it goes. Okay. So I'm just considering 0 is quite easy, so we'll go with 0 1. So how 0 1 will look like: A of 0, I 0, J is 1. How this will goes? This will go to A, this node, the J is n minus 1, and I is 1. I goes to 1, J goes to n minus 1. Yep. And for A of 1, yep, now we are considering this node n minus 1, so this node goes to this node. Here the J is n minus 2 and I is n minus 1. A of n minus 1 and n minus 2. Okay. So for this node we move to this node, which is here I is equal to n minus 2, J is 0. A of n minus 1 to n minus 2. Okay, this will go to A of n minus 2, J is 0. Similarly for the last one, which is A of n minus 2 to 0. Okay, this will goes to a of 0 and 1. Yep, this is how we complete this node. Similarly, this node, and so on. So okay, so how our algorithm will look like. So if you examine one thing, so here we start with this node, we move in this direction, here I same. Okay, so let's evaluate our program. So a of I and j. Okay, so here I is same, here j is same. Okay, so I0 will go to n minus 1. If I is equal to 1, I is 1, it consider the second row, which is n minus 2. So similarly, if I generalize away, it's like a of, now in this direction, if I is fixed, here the j is fixed. What should be the j is n minus 1, because for 0 it's last row, and rest for 1 n minus 1, for 2 n minus 2. So similarly, n minus 1 minus I. So this is a generalized way of writing the nodes. Okay, so how I will change. For I is equal to 0, j is 0. For I1, j1, I2, j2, I3, j3. Yep, so I is replaced by j. Yep, this is how our first node will look like. Okay, so how the second node will look like. So this is the same function. Okay, so let's say if this was of and x and y. Okay, so here's x. Here if you see in this direction, how x behaves, x goes incremental and j goes the same, y goes the same. So if y goes the same, so here I goes the same, which is x. So here if y equal n minus 1, here x is n minus 1. If y is n minus 2, x is n minus 2. So it says ki here y is the same as x. Similarly, if you consider as y, how x goes, so x increase, x is 0, here n minus 1, x is 1, n minus 2, x is 3, n minus 3 is the same behavior, n minus 1 minus x. Okay, so if you compare these two formula both are same. So similarly, all the formulas are same. So what we do, so we will generalize our node via this formula itself. So let's say we get the formula for first node, we start writing the formula for other nodes also. Okay, so how the what will be the second node? Second node is j n minus 1 minus I. Yep, okay, so if you this one for the second node. Okay, so this was a x is j. So how x was written is n minus 1 minus j. So n minus 1 minus j. Okay, and this is our y, and it was same as y. So this is n minus 1 minus I. Yep, so this is our second row. Okay, so how our third row will look like. Third position, not row, third position, it's good to call it a position. Okay, so third position is similarly, if this is the starting node of third position, a of n minus 1 minus I, n minus 1 minus j. Okay, this will go to, how this will go to, so yes, so this will, if we look at this formula, which is the same, so a of y is x is equal to a, then it is a of n minus 1 minus j. Okay, and how this x goes to n minus 1 minus x. N minus 1 minus x. What's x here? X is n minus 1 minus I. N minus 1 minus I. Okay, so if I open this formula, it will be something like a of n minus 1 minus, sorry, can I move this to okay, I will write it in the next line. It's n minus 1 minus j of n minus 1 minus n plus 1 plus I. Yeah, if we so minus n goes to minus n, and plus n cancels, minus 1 and plus 1 cancels. So this is our third position. So fourth position will be fourth position is a of n minus 1 minus j and I. So if you remember fourth position, the first position itself, which is a of ij, a of I and j. Okay, so we will start from 0 to n minus 2, considering n minus 2. We will not consider n minus 1. Last node we will not consider. If we go to I equal to 1, then we will not consider this one because this is already rotated. We will consider from this one. So for I equal to 1, we will consider from this node. For I equal to 2, we will consider from this node. Okay, so let's how our formula will look like. So yep, so just we can write the code now. So how the pseudocode look like? Sorry. Okay, so the pseudo algorithm. So int start with int I equal to 0, I less than n, I plus plus. Okay, so for j, sorry, for j, from where j should start. So for I equal to 0, we will start from j 0 itself. For I equal to 1, we start from 1 itself. For 2, we start from 2 itself. Yeah, j will start from I itself. Okay, and where does j lands? J less than n minus 1 will j n minus 1 minus I. So it's like for I equal to 0, we will reach to this node. We will consider till this node. For I equal to 1, we will consider till this node. So n minus 1 is the last node. We will not consider minus I and j plus plus. Okay, yep. So a of I j. What's a of ij? A of ij is a of n minus 1 minus j, this node, n minus 1 minus j and I. So that was that node, the fourth position node that moves. Okay, similarly a of ij is overridden. We need to store it in temporary location so that it will be used by the last node. Okay, so now second last is this one. What's the value of the, sorry, so yeah, this was the third position. What, there's something happening actually. I will write it by myself itself. N minus 1 minus j of I equal so it was this one, this node, and a of n minus 1 minus I of a of n minus 1 minus j. n minus 1 minus j. What this one? Okay, third node was this itself, a of n minus 1 minus I of n minus 1 minus j. This goes to a of j to n minus 1 minus I. Yep. So what about the last node? A of j n minus 1 minus I. Okay, so this was a of ij, which is our temp variable. So this is how our pseudocode will look like. Let's copy all of this and try to so yes. So if some basic check, int n is a matrix root length because we consider is n. If n less than equal to 1, if let's say square matrix of size 1, we don't need anything. If size is not equal, it's not a square matrix, then we again don't do anything. Okay, now then we start our program. Okay, yep. So okay, what's a is matrix itself, so we override a to matrix itself. Okay, yes. So anything else? Cool. So let's run the code for basic test case. So this, okay, j is not initialized, my mistake. Oh, this is accepted. Let's try to submit this code. Oh, it ran 0 ms 100% faster. Oh, that's great. So thank you guys, hope you like this video.